and today I'm going to detail how and why amyloid beta protein particles, which are one of the most well-known features of Alzheimer's disease, can also accumulate in the bone marrow. Amyloid proteins, also known as fibrils, can accumulate in almost any organ or tissue, and this condition is generally referred to as amyloidosis. This accumulation of amyloid fibrils occurs as we age, primarily because of a decline in the body's system of protein quality control, known as the proteostasis network. You can think of this complex network as essentially a protein factory that oversees the construction, production, transport, and eventual recycling of thousands of metabolic proteins. As we age, this network, like many other parts of the body, grows less efficient, thus allowing misfolded proteins to escape degradation and aggregate into amyloid fibrils. Skeletal vitality holds a unique connection to Alzheimer's disease because people with osteoporosis are often more susceptible to developing Alzheimer's, and bone loss is frequently detected early in the progression of Alzheimer's, often preceding substantial cognitive decline. There's also a strong correlation between fat tissue dysregulation and amyloid fibril deposition. And this is one reason among many why Alzheimer's is sometimes informally referred to as type 3 diabetes. Today, I'm focusing on bone tissue because both fat cells, known as adipocytes, and the bone-building cells, known as osteoblasts, originate from the same stem cells in bone marrow, and lifestyle factors that favors one of these two usually inhibits the other. As we age, the balance tips toward fat cell formation, leading to increased fat content in the bone marrow, and decreased bone creation, which definitely contributes to the bone loss seen in a condition like osteoporosis. Cellular senescence, in which aged and damaged cells accumulate over time, along with concurrent inflammation, is unfortunately an unavoidable part of aging. Senescent bone marrow adipocytes abundantly secrete a protein called serum amyloid P, which then promotes the formation and deposition of amyloid fibrils. Serum amyloid P is normally a component of the innate immune system that binds to molecular debris, thus marking it for uptake and clearance by cells like macrophages. However, the numerous aging factors that contribute to the chronic low-grade inflammation known as inflammaging can disrupt and redirect this process. So instead of promoting clearance, the binding of serum amyloid P to amyloid fibrils stabilizes them and protects these fibrils from normal proteolytic breakdown. These amyloid deposits then impair the function of the bone-building cells, known as osteoblasts, while conversely activating osteoclasts, which break down bone, thus greatly accelerating bone loss. Insulin resistance, which is common as we age, and obviously with a condition like obesity, is a major contributor to bone marrow adipocyte senescence and eventual amyloid beta deposition. So it's easy to see that maintaining insulin sensitivity and optimal bone density are two critical strategies for avoiding the inflammatory conditions that facilitate amyloid deposition in the bones. Unfortunately, there are several natural ways to do that. Regular daily exercise, and most especially weight training, is the single most effective way to maintain both optimal bone density and insulin sensitivity. And as part of this, daily intake of CoQ10, or even its active form ubiquinol, helps in several ways, most critically by enhancing the expression of osterix, a transcription factor that promotes the development and maturation of osteoblasts, while also significantly reducing oxidative stress, protecting the insulin-producing pancreatic beta cells, and maintaining optimal levels of ATP, which means CoQ10 gives you the daily energy you need, regardless of age. Pyrroloquinoline quinone, also known as PQQ, is a natural companion for CoQ10 because as CoQ10 increases mitochondrial ATP production, PQQ directly initiates the growth and maintenance of mitochondria, while also directly supporting the development of osteoblasts. Similarly, calcitriol, the magnesium-activated form of vitamin D, also promotes the development of osteoblasts while also deactivating the inflammatory P38 MAP kinase pathway, which is otherwise responsible for the cascade of inflammatory factors, known specifically as the senescence-associated secretory phenotype, that propels the senescence process. So this should hopefully show you that amyloid particle accumulation is not limited to the brain, and that cellular senescence and the systemic inflammation behind it are the primary drivers, along with numerous lifestyle factors. And while there are several things you can do to fight its progression, like Alzheimer's, it's best to begin as early as possible. So don't waste any time. Thanks for watching. I'm Jason Carter, and I'll see you next time on ENZYMENTAL. Stay healthy.